Can you run a local AI assistant on a regular desktop PC with a fairly budget GPU? Since Qwen 3.6 released, maybe we can? We're going to run some benchmarks that simulate the kind of demands an agentic harness like OpenClaw, Hermes Agent, or Pi would place on the system, directly comparing two GPUs and aiming to answer the question, are we in range now for a local AI assistant? My ancient hand-me-down NVIDIA GTX 1060 6GB is still chugging away in this system, and it's been serving small models to me for quite a while. And this is still a fairly budget new one, a 5060 Ti 16GB that cost about £480. So with that new card, and to compare the old card, can we run it? First, what harnesses wanted? It used to be flagship models only. Realistically, we're talking Claude, Opus, or the latest GPT. That's pretty much it. Anything else that you run and you will get less than stellar results. But it's 2026 now, and there are some pretty good alternatives, even at the API level. Things like GLM or Minimax, DeepSeek V4 probably, although that's so new that I haven't seen much on that being used this way yet. I'm sure it still performs brilliantly. These things are still big models and they're going to run in the cloud, but they're not Anthropic Claude and they're not OpenAI's GPT, which means that they cost quite a lot less. I think most of them are about a third of the price, if not lower, than, say, Opus 4.7, the current probably best model that you could use for these agents. A great indicator of the performance of these models in something like OpenClaw is PinchBench. PinchBench aims to benchmark the kinds of things that OpenClaw would ask of various models and see how well they perform. There's quite a lot of different models in here that seem to do well. It at least indicates that you now have a lot more choice. There's not a gulf between these things, especially if you go to, say, somewhere like a decent, well-known Reddit forum and, well, what do the vibes say there? I tend to spend quite a lot of time on local Llama, or rather, Reddit gives me a gazillion notifications a day from local Llama. And a lot of them are people's real-world experiences using these models in things like OpenClaw and Hermes Agent and Pi and all these things. Seems to be the feel is the flagship models are still the best. But Qwen 3.6 in particular is really catching up, and that just might be something we can run locally. There's a couple of models of interest when it comes to Qwen 3.6. There's a 27 billion dense model, and there's a 35 billion, active 3 billion mixture of experts model. And the attraction of that is it should run much, much quicker. In fact, the mixture of experts model came out first. That's what made me give this a go. I did a quick sense check here to see whether it could run at all and how it would compare to Qwen 3.5, 9 billion parameters, which is a smaller, dense model that I run every now and then for chat. As you can see, I don't get a massive speed out of this model. This is the token generation. It's a couple of tokens, which is almost a word. It's about, yeah, it's slow. A word per second is going to be pretty slow, but it can function even on my old card. By comparison, the new one is faster already, even on this old hardware. So, given that at least the people on the local Llama subreddit suggest it's a pretty good model to run in these harnesses, maybe it's time for a bit of an upgrade, and maybe I can get a pretty decent speed out of it with some new hardware. So I'm not going to download all the agents and to try them. It's not a very scientific way of testing anyway, so I want some kind of benchmark that compares how they all work. So the critical question is, what do the agentic platforms generally do with the model? In particular, how much context do they throw at it before they ask it to go and process the user prompt? Typically, about 5,000 tokens for OpenClaw. That's already more than Ollama uses for default for its models. Its default context window is limited to 4,000 tokens. So we already need custom model files that have a larger context to be able to realistically run OpenClaw with Ollama. Hermes Agent, I've seen reports of about 13,000 tokens. These things are probably moving targets, but these are defaults. Pi is very minimal and has less than 1,500 tokens. Again, this is default setup and really from some loose Googling. But it's a pretty decent ballpark to know how much is going to get thrown at this model before any user content goes in there at all. And of course, there's more. If you have MCP tools, you are throwing thousands of tokens because they get fully specified and passed to the model. Not particularly efficient. But if you use skills, that can be a bit better. There's a progressive disclosure mechanism that means that might be only 100 tokens or so per skill, a short definition of what the skill is and does. The model can then decide if it needs to figure out the rest of the skill detail. Put all this together, and what does that mean for hardware requirements? RAM and VRAM. Pretty much one of the most valuable things in April 2026 when it comes to computing. The price of these things is skyrocketing. It's not a great time to upgrade consumer hardware, realistically. If you're in Apple land, maybe running a Mac Mini or something like that, then you have combined memory, your RAM and your VRAM. It's sort of the same thing. As I understand it, there's a slightly lower inference speed. It's not as fast as a dedicated GPU, but you have all of that memory available so you can run pretty large models. Likewise, the DGX, Spark, and Strix Halo, I think. I don't know. I'm not spending thousands of pounds for a box that sits in the corner. I've got this PC already. I'm wondering if that can step up to the plate. There were some architecture changes between Qwen 3.5 and Qwen 3.6 that mean that the latter can run with slightly lower memory requirements than the former did. So does that mean that lower amount of VRAM that we might find on, say, this 5060, 16 gigabytes, maybe that's enough now? That can make the difference between spending thousands on a GPU and spending under 500 quid. First, a major caveat. Let's not pretend that a local model is going to be able to solve all the problems that you can throw at your agent. You are still going to need the flagship models. But hopefully, if you have some options for model failovers, you might be able to start with the cheap local model that costs only your energy and see if it can solve the problem and upgrade the model if it can't. That could save quite a lot of money. The opposite approach is also fine. Many will advocate just using the flagship model. If you're doing this for business, after all, you've got an experimentation budget. I assume you could throw that money entirely at inference and then downgrade it when you know what you're optimizing for. It makes perfect sense, and it's a reasonable way to go about it because you know that you're working at the absolute peak of what's possible. But I prefer to experiment knowing that the cost is minimal and then use more expensive things when I need to. That's also why I quite like the idea of Pi. The context is going to be super minimal and I can add things as I require them. Upgrade models as I need a smarter brain. That's the approach I'm taking. And you'll note I mentioned energy. Local AI still isn't free. Your GPU doesn't draw a lot of power when idle, and that's going to increase when you are running LLM inference on it. So we should measure that too, so we can properly compare the cost of running local AI versus calling an API. So firstly, real simple test. We're actually going to just run this model using Ollama on the local PC. If you know a little bit about running local models, you might be wondering why I'm not using another inference engine. I might be able to use LLM Studio, VLLM, I might use Llama.cpp. There are loads of these. But Ollama is pretty much the simplest to run, and it's a great indicative way of seeing, can it run on this system? It's very good at figuring out how it can fit things into the current setup, which is pretty ideal for a PC I'm actually using day to day. Perhaps that's why Ollama is so popular. You install it, download the model, and you just run. So rather than you watch me chatting with an AI, which you've probably seen a million times over and done yourself and ChatGPT, I'm going to go straight to the benchmarks I've already run for this 1060 6 gigabytes that's in the system. This is really a baseline. How slow is it? So I'm running something called Llama Benchy, which is going to allow me to put a whole chunk of stuff in the context window and then run a small user prompt on top. And I can define how much is in the user prompt, how much is supposed to be already in the context, and simulate some of these different agentic environments. Let's look at the most simple example, which is the 4K context window. That is the default with Ollama. And it's pretty painfully slow, between 6 and 7 tokens per second. It wasn't even particularly dependent upon how much context was in there already, because it's so small. So 6 to 7 tokens per second is, well, it's really too slow to use. You can see I've also run different context sizes here, 32K, 64K, 128K, even 256K, which might be a surprise given that it's normally a massive RAM requirement or VRAM requirement if you have a large context, but Ollama still managed to make it work. Not that much slower, still 5 to 6 tokens per second. Is it now going to work with a new card much faster? And are we going to get local agentic AI working? Well, next thing for me to do is shut all this down, put the card in, and let's see what happens. Well, quite a lot of time has passed. The new card is in, finally. Yeah, it was 1 centimeter too big for the case that I already have, so I had to buy another case, wait, install it, and it's now in there ready to go. I basically forgot to tell you some of the other bits of hardware that I've got and how that affects things. So I have AMD Ryzen 5 5600. It's an alright processor, nothing amazingly fast, but it's not particularly old. But more to the point, I've got 32 gigabytes of RAM. Models are pretty big, so 32 gigabytes is probably a minimum if you're going to try and run these things in, say, Ollama at Q4 quantization. That's a pretty big file. It's going to want quite a few gigabytes of RAM, and Windows is a bit of a memory hog as it is, so it's taken up quite a lot of that. It would be much easier if I had 64, but RAM is extremely expensive and 32 is enough, realistically. We actually had to close quite a few apps when we were trying to get Ollama to run on the 1060. There's only 6 gigabytes of VRAM available on that card, so it needed quite a lot of the RAM. I had to close quite a few things. I couldn't leave Cursor open, for example. That wanted 1.5 gigabytes of RAM usage, so lots of things had to get shuffled out so that I could do it. Not exactly practical, but not a problem either, because now I've got a 5060, so I don't need to do that. So let's take a quick look at the results. So I started with Ollama because I could get a like-for-like comparison, but it's not the most efficient way of using the 16 gigabytes available because it's still not going to fit. The model at Q4 quantization, which is what Ollama uses, is still too big. So it's going to spill over into RAM, and that's going to hurt speed. But let's look at that first. And you can see that what was between 6 and 7 is, a little bit less than 2 times speed up. That would be disappointing if that were all I were intending to get in terms of benefit from upgrading the graphics card. But there's no point in sticking with Ollama here. The point was to fit the model entirely into all that extra VRAM that we've got, which means moving over from Ollama to Llama.cpp, where I can use one of Unsloth's smaller quants. I chose the iQ3XXS, a Q3 quant. It's smaller, and with the new architecture reducing the amount of VRAM required for the cache to fit all that context in, we can fit 128K with that model fully in VRAM. So when we run it that way, well, that's quite a lot faster. And we're talking now the kinds of speeds between 65 tokens per second, and that's at 64K context usage. So that's really at the limit beyond which you're going to start compacting and removing things out of that context anyway. So if we've gone from 2 times speed up to 10 times speed up, and yes, we've gone down a quant size, so we've maybe lost a little accuracy, but in an agentic harness, hopefully the advantage of being able to test the outputs and keep trying will overcome any minor shortfall in intelligence that rounding produces. We are also able to fit a similar quantized level of the Qwen 3.6 27B, the dense model. That also fits in. So we can see it's a bit slower, but, well, by how much? Well, between 6 and 15 tokens per second. Yeah, that's quite a lot slower than the 35B A3B. So we still sort of have a preference for speed of using the mixture of experts model. Perhaps not a surprise. But the internet tells me that if you want something specific and in-depth doing, like perhaps coding, bug fixing, that kind of task, then maybe it's worth bringing in the 27B for that. It will fit, and it's okay. It's not terribly slow. And you can see we're getting very similar prompt processing speeds here, coming in at another 66 seconds to load in an extra 3,000 tokens worth at a 65K context usage. But it's a lot faster down this end. It's all about cost. We want to compare the use of this now practical local model, particularly the 35B, A3B model, versus using an API. The speeds are already comparable, so what about cost? Well, I calculated over the entire test run the input and output tokens for the various APIs, and I compared that with the energy cost. I then rounded it down to the nearest cent. So this is how Qwen 3.627B cost, and back on the 1060 comes at a rounded cost of 0. To use the same model on OpenRouter, that's offered by Deep Infra, would have cost me a cent. But if I were having the same input-output tokens out of Claude Opus 4.7, we'd be looking at 15 cents. Now, of course, it's not a perfect comparison. The Deep Infra model is at FB8 quality. This local Ollama one was at Q4, and Claude Opus is in its own league and will produce markedly different inputs and outputs. So we can't guarantee it's a like-for-like comparison, but it's as close as we can manage. The results are fairly similar at different context sizes when we were modeling 35B on Ollama on the old card. But what about now? Let's jump to how we're actually going to run it via Llama.cpp with 128K context. And this 35B model cost me a whopping 4 cents of local energy to run. The equivalent API would have been 31 cents, and that would have cost us nearly $10 in Claude Opus. So this really does offer pretty decent value for money. And just for comparison, the same can be said of the 27B. So how can we run both these models on the same machine with only 16 gigabytes available? Well, we're going to have to swap them in and out. People used to use a separate utility called Llama Swap, still works fine, but Llama.cpp has started shipping a router capability, and you can define an ini file like this with some defaults for all models and sections for each model that you would like to also serve. I've put a couple of presets in here. It's worth remembering that the cache is bust every time you swap models, so knowing which model is loaded and using that model becomes quite important for your agent harness. If it's working on anything with a reasonably large context, we don't want to have to pay the 300 seconds plus to load 64K in, all in one go. This includes thinking mode, as that changes the chat template and will bust the cache. So we can't toggle thinking on and off for the same model without losing all of the prior context and having to reload it in. I can also run a separate router for CPU-only models. This will keep them totally off the GPU and allow, for example, 35B, A3B to chug away on there while we have some light model doing, for example, little tasks that Open Web UI might ask of it, like labeling chats or offering follow-up questions. So it works. 35B, A3B at least works pretty fast. So what use cases are now in range for running on a local PC with fairly budget GPU? Well, like I said right at the top of the video, we can't pretend that we won't need an API. For the more complicated stuff, we are going to have to tag in Opus and say, take care of the hard bits. So we want an agent harness that can upgrade the model when needed. That might seem like it's not such a big thing, but lots of harnesses don't really allow model switching very easily. So we are going to want something that can actively do that, but also doesn't do it too often. For example, we didn't want to swap from 35B to 27B and bust our cache all the time. We want to do it at phase boundaries between jobs fully completed by one model and jobs ready to start afresh with another. We could try higher quants to try and get a little bit of extra smarts out of the models, particularly with Qwen 35B, A3B, we can offload quite a chunk of that and it still retains some speed because of its mixture of expert structure. But why bother when we have it running entirely in VRAM right now? Unless it turns out it's a total dunce, this is a great fast way of getting local inference working for us. And if we need something better, we go off to an API. So we're now ready for a free at first approach to building a local and private AI assistant, working on real business workflows, working on client data that we must keep private and for way cheaper than any zero data retention API would let us. I'm pleased. Time to start using it. Over on our school community, I will pop the links to the models that I'm using successfully locally that all fit in VRAM. I'll chuck up those ini files in case you want to use the router functionality of Llama.cpp yourself. And I'll also maybe drop a short video that explains how I got it to load on startup natively on Windows. So that's it for today. Next thing that we're going to move on to is setting up Pi as a personal AI assistant. It's got small context needs and it's going to really run like a beast on this local Qwen model. I'm looking forward to it. See you then. And are we going to get local agentic AI working?
If you like what we've been doing here, hit the like button. And if you want to keep up to date with our progress and see actual walkthroughs with implementation details, hit subscribe. If you want to get involved, go check out our school.com community link in the video description. We're right at the beginning with this, so it's completely free right now, and you get a chance to help shape this early community of fellow business owners and operators actively implementing AI right now. There'll be tons more interactions and content there than we could ever squeeze into a YouTube video description or comment section, so go take a look, and don't be afraid to join and introduce yourself. All we ask is that you be on the path of actually implementing AI in your business. But if you just want to keep watching here, this is the full current implementing AI playlist, and this is our most recent video. Enjoy.